right, we're going to walk through the answers now to your example problem. We aren't sure if this is exactly how your 25-minute question will go. In talking to other teachers from around the country who are also thinking along what they've heard and think, we've kind of come to the conclusion that we think your 25-minute question will be a whole lot of mini things like this question was, and your job is to just try to get as many of them right as you can in those 25 minutes. You're probably not going to get done. Many of you probably didn't get done in 25 minutes, and that's okay. You're just trying to get as much as you can in. So I'm going to walk you through the answers and then also try to give you an idea where points were coming from, and then you can kind of score this yourself. I have no idea what a 5, 4, 3, 2, or 1 would be. Typically, the average on free response problems is a 3 out of 9, or maybe like a 3.3 out of 9 from year to year. So if you kind of consider that the average, that's probably a third of the points is what you need to get a 3. And then if you got, say, close to half, that might be a 4. If you got 60%, something like that, maybe that's a 5. But those are just guesses. Don't hold me to that. We'll have to see when you really take it. So they gave you this graph. They told you this was f prime x. So this is our derivative graph. And we see that this area here was 10, this area was 35, and this area was 30. And they don't tell you anything about over here. And we're told that it has horizontal tangents at 1, 3, 5, 7, and 8. So where we would expect them to be, we can be sure that that's exactly where those are. Okay, so for what interval is f of x increasing, and justify our answer. So f of x is going to increase when its derivative is positive, and this is the derivative, and this was positive from 2 to 4 and from 6 to 9. Again, we were only looking to 9 anyway. So I would guess you would get a point for having those intervals correct, and then we would say that that's where f prime of x is positive, and you would get a point for that explanation. So a pretty nice one to start off with. We go to B. For what value of x does f of x have a point of inflection? So since this is the derivative, when the derivative is increasing, f will be concave up. When f is decreasing, f will be concave down. So anywhere it switches from increasing to decreasing or from decreasing to increasing, that's going to be a point of inflection. So all of those horizontal tangents that they told us, 1, 3, 5, 7, and 8, those are your points of inflection. And we'd say that's where f prime of x switches from increasing to decreasing or decreasing to increasing. All right. You don't really have to get into detail about when it does one or the other. The fact that it switches makes it a point of inflection. So you get a point for the answers, and I would believe a point for the explanation there. Okay. List all the critical points for f of x and label them as relative max, minimums, or neither, and give justification. So a critical point is when our derivative is equal to 0 or is undefined. So we're going to have 0 at 0, but it's an endpoint. So we really aren't going to have a relative min or max there, so we don't have to consider the endpoint. We do, though, have to consider 2, 4, and 6. So x equal 2, x equal 4, and x equals 6. Okay, and I believe you'd get a point for listing those as your critical points. At 2, our derivative is switching from negative to positive, so that would make that a relative minimum. All right. At 4, it's switching from positive to negative. That would make it a relative maximum. And 6 is also switching from negative to positive. So we actually probably could list that with it, or if you want to rewrite it. Again, time is going to be really critical. So if you can save yourself a little bit of here, that might be better. So at x equal 2 and 6, those are relative minimums because, or maybe I'd say it like I did before, that's where f prime of x switches from negative to positive. And just stay calm during your test. Don't make don't start getting crazy and panicked. just kind of do a lot of the problems. I think you'll have a good clue on what you're supposed to do. So feel good about the ones you're doing and getting right. All right, time like this, you know that you feel you got this one in the bag, and so you can feel good. So the critical points will get you a point. Labeling those two as minimums because that's where the derivative switches from negative to positive. This is a maximum. That's where the derivative switches from positive to negative. That would get you another point. Okay. Then we get to D, and it says, what's f of 6? So they told us in this one that f of 2 was 5, so that's a beginning value. When you're at 2, the function value is 5. If we want to get to 6, all right, so I don't know what I was right there. So f of 2 is 5. If I want to get f of 6, what I need to do is I have to accumulate this, right? So this area right here represents how f changed from 2 to 4. It changed by positive 35. And then from 4 to 6, it changed by a negative 30 because it's a negative area. So in other words, we went up 5 from 2 to 6. So if we were at 5 to begin with, f of 6 would be 10. Now it doesn't say to justify, but if you wanted to put a little justification here, you could say that f of 6 was equal to f of 2 plus the integral from 2 to 6 of f prime of x. And f of 2 we know was 5, and this area here was 5, and that's where we get 10. So I believe you're just going to get a point for something like that. Unless they tell you to write a definite integral to represent it, then maybe you get a point for the integral and a point for the answer. But without the justification, I think it would just be a point. Okay. What is the minimum value for f of x from 0 to 9? So what we want to do is we want to list our candidates. Okay. And we should always consider the endpoints and any of the critical points. So we're going to go ahead and put 2 and 4 and 6 down. Okay. Now we were told that f of 2 was equal to 5. All right. When we go to 4, we've added 35 to it based on that graph. So that value will be 40. When we get to 6, we've taken 30 away. So now we're at 10. And then when we get to 9, we've added some value, but we aren't sure how much. So we know it's more than 10. How much more, we don't know, but we're looking for the minimum value anyway, so that isn't going to matter, right? Well, we have to now test it. Right now, 5 is the leader, but we have to see what was going on at 0. So that one, you can kind of confuse yourself on here. I'm trying to figure out what f of 0 is. Now, the best way to think about this is whatever f of 0 is, I'm going to take 10 away from it. I'm going to subtract 10 because that's negative area. We'll take it away, right? So I'm going to take 10 away, and it's going to give me 5. So what would I have to have started with so that if I take 10 away would give me 5, and that would have to be 15. 15 minus this 10 would give me 5. So this value right here is going to be 15. And so what's my minimum value? 5 is the minimum of f for 0 to 9. And I believe you get a point for showing this table some justification that you're doing these values here, and then a point for the answer. That some 2-point combination would be my guess on something like that. Okay. Letter F says h of x is equal to this. Now we see we have a product rule kind of starting up here. We want to know what h prime of 2 is. So we got to figure out first what h prime of x is. Product rule would say take the derivative of the first times second as is, plus keep the first times the derivative of the second. Okay, I believe you get at least 1 point for doing something like that, maybe 2, depending on how they want to score it this year. And then h prime of 2 will be 2 times f of 2, which we were told was 5, plus 2 squared plus 1 times f prime of 2. Now, f prime of 2, since this graph is f prime of 2 would have to be 0. That's where it hit the x-axis. So this is going to be 0 right here. So that zeroes out. We get 2 times 2 times 5, which is 20. I believe you get a point for that right there. Okay, so that takes care of the first part. And then what happens is they give you a table and they start asking some other questions based off the table and what we're doing here. I'm going to do that in the second video.